Assalamualaikum and hi to everyone, especially to my lecturer, Puan Aliza binti Wan Atan. Today, me and my friends from Polytechnic Sultan Salahuddin Abdul Aziz Shah, one of the group of DKM2B, wanted to present our first presentation for engineering mathematics 2 subjects. So the topic contained in our presentation is application of differentiation and perform application of differentiation in real problems. Now I would like to introduce my group members to everyone. The first one is me, myself, Muhammad Zaid bin Rosli, 08 DKM2381289. Second, Muaz Zafran bin Abdul Halim, 08 DKM23F1050. Next, Khairul Hafiz bin Aziz, 08 DKM23F1187. And lastly, Muhammad Amirul Naim bin Azhar, 08 DKM23F1115. So, in this presentation, we will explain about introduction, about application of differentiation and the example of the question, and also introduction of differentiation in real problems and the example of question, and lastly, conclusion. So 2.7 application of differentiation. Hi, my name is Zahid. Today I would like to present about introduction about application of differentiation. Differentiation is widely used in science and engineering field. It can help us solve many types of real-world problems. Some applications of differentiation include tangents and normals, Newton's method, rate of change, finding maximum and minimum points, and curve sketching. In this chapter, we will discuss about finding stationary points by using differentiation and also learn to sketch graph. Next, stationary point. There are three types of stationary points. The first one is maximum point. The second one is minimum point, and the last one is point of inflection.
Assalamualaikum and hi everyone. My name is Muaz Zafran bin Abdul Halim. My metric number is 08 DKM23F1050. Today I want to do example for application of differentiation. The question is given a curve y equal 2 plus 3x power 2 minus x power 3. Find the stationary point and sketch the curve. Step 1 is 1 equal 2 plus 3x power 2 minus x power 3. Differentiate dy per dx equals 6x minus 3x power 2. Step 2, we must to find stationary point. 6x minus 3x power 2 equals 0, and we can simplify 3x multiply 2 minus x equals 0, and stationary point for x is 0 and 2. When stationary point x 0 and 2, stationary point for y 2 and 6, and then stationary point equal 0, 2 and 2, 6. Step 3, we must to find minimum point and maximum point. Firstly, we must to do differentiate. Differentiate equal 6 minus 6x. When x equals 0, differentiate is 6, and then 0, 2 is a minimum point. When x equal 2, differentiate is negative 6, and then 2, 6 is a maximum point. And the last step is we must to sketching curve. When x equals 0, y equals 2, that is a minimum point. We must to put point at the vertical point y. And when x equals 2, y equals 6, that is a maximum point. We must to put point at the cross point x. After placing the point, we must to write the answer. The answer is y equal 2 plus 3x power 2 minus x power 3. After placing point and write the answer, we need to make a line at the edge point. That's it for me. Thank you.
2.9. Perform application of differentiation in real problems. Introduction. One of the more important applications of derivative in real problems is calculate rate of change. Differentiation allows us to find rate of change. For example, it allows us to find the rate of change of area with respect to time.
Assalamualaikum, my name is Khairul Hafibi Aziz, and now I want to explain the question about the rate of change. The question is a steel cube with border X increase because of long-lasting heating. Border X increased by 3 mm per second. The original length of the border is 12 cm. And last, this question is determine the rate of change of the surface area for the cube. Now, we need to put out the information in this question. And now we need to, let's say, X is equal to the original length of the border. The original length of the border is 12 cm. So, X is equal to 12 cm. And the question gives dx per dt is equal to 3 mm per second. But we need to change the unit mm per second to centimeter per second. After change the unit, the answer is 0.3 centimeter per second. And the formula surface area for the cube is 6a square. But we need to change x to a. Why need to change? Because x is given. So we need to change a to x. So the surface area is 6x square. And we need to differentiate the surface area. After differentiating the surface area, the answer is dA per dx equal 12x. And lastly, the formula rate of change is dA per dt equal dA per dx times dx per dt. dA per dx is given. dA per dx is equal to 12x. S is given. S is 12 centimeters. So 12 times 12 times dx per dt. dx per dt is equal to 0.3 centimeter per second. And the last answer of the equation is 43.2 centimeter square per second.
Hi, my name is Muhammad Amirul Naim bin Azhar and my metric number 05 DKM2B F1115. Differentiation is a fundamental concept in calculus and mathematics in general. The conclusion of differentiation depends on the context in which it is applied. In calculus, after differentiation, you typically have the derivative function, which represent the rate of change of the original function with respect to its variable. Its derivative function can provide variable information about the behavior of the original function, such as critical point, extrema, and concavity. Additionally, differentiation is used in various fields such as physics, engineering, economics, and more to analyze rates of change, optimization, and other important phenomena.
And that's all from us. Thank you.